mechanism in which a signal is triggered by a mechanical force applied to biomolecules such as shear stress or a pull or push. Normally, such force would cause a conformational shift in the protein or receptor, exposing functional regions to the environment. The signal used in a mechanical signaling system are semaphore signals. These signals are operated by means of either a lower quadrant or an upper quadrant signaling system. Mechanical signals are usually remotely operated by wire from a lever in a signal box, but electrical or hydraulic operation is normally used for signals that are located too distant for manual operation. For lower quadrant signaling system, this system of signaling was designed so that the semaphore arm of the signal could be kept either horizontal or lower. The lower left-hand quadrant of a circle is used for displaying a semaphore indication to the driver of a train. This concept was possibly developed based on the left-hand driving rules applicable on roads in the UK and also in India. Next is upper quadrant signaling system. Due to the lower quadrant signaling system limitations, the upper quadrant system was developed, which can display more than two aspects. In this system, it is possible to incorporate three positions of the semaphore arm. As you can see in the picture, which is horizontal, inclined at an angle of about 45 degrees above the horizontal level, and also vertical.
First, I will explain about advantages. Most signaling systems use track side signals to control the safe movement of train and tell drivers what to do, such as like regulate the movement of the train so that they run safely at maximum possible speed. Second is to maintain a safe distance between trains that are running on the same line in the same direction. Third is to ensure that the safety of two or more trains that have to cross or approach each other. Lastly, to provide facility for safe and efficient shunting. So, let's move to the disadvantage. Meanwhile, multiple trains will have been stopped by red signals, and so it's not necessarily a quick fix to get the thing moving again. Signaling systems are also vulnerable to a wide range of risks ranging from flooding to lightning strike. This can cause failures that are difficult and time-consuming to resolve. First is about extreme heat. Very high temperature can affect signaling system, causing them to shut down. They can also affect train detection system. Second is about the faulty components. Faults in all types of electronic, electrical, and mechanical components can result in a system failure. A complex system is made up of many thousands of individual components, and duplication is not always possible.
Next, will be discussed about the impact of mechanical signaling to railway industry. Railway signaling system ensure the safe operations of the railway networks with their reliability and maintainability. They really affected the capacity and availability of the railway network in terms of both infrastructure and trains. Versions of signaling known as the time interval system, which is the train will be arranged by the time interval of 10 minutes to clear the blocks of train, and the signals with level controlling remote signaling and points in 1860. The impact of mechanical signaling is it increased the available braking distance for train crew, thus allowing higher speeds.
Railway signaling system is good to ensure the safe operation of the railway network. The functionality of the signaling system is based on the principle of fail-safe. This means that the railway section where a failure is located will be not fully operative until the failure is repaired, since the safety cannot be ensured. So hence, the dependability of the system directly affects the capacity of the network. As we saw, for many years, mechanical signaling went through the process of constant evolution and adaptation to the new technological and market circumstance, from flex to mechanical and light signals to the point where signals are no longer even required and wall communication done between the railway infrastructure and the train drivers kept in real time, optimizing the train speed and braking pattern automatically.